All right, thank you, Rob. So I'm David Gerouville-Farrell. I'm a consultant, and for the last 2 years, I've been working with a really great digital agency from just down the road called Caution Your Blast. And Ali in the front row with me is from Caution Your Blast today. And what we've been building is an AI-based product for the UK Foreign Office, the FCDO. And there's a lot of things that are different about working in that really, really risk-averse context, and there's lots of trade-offs you have to make and lots of compromises you have to make, and that's what this talk's about. So it's like a case study basically of this thing that we built and that we launched earlier on in the year. In order to set the context, to take you on the journey of us building this thing, you need to remember what it was like 18 months ago when GPT-4 came out. I don't know if you can remember those halcyon days. You can't probably read it very well at the back, it's a bit blurry, but this paper says GPT-4, a new era of AI in medicine. And there was some speculation that we might not need doctors, right? Which is kind of wild. There was the better news when the GPT-4 passed the bar exam, and for a hot minute we thought we might not need lawyers. But the paper that got me personally, genuinely, I could not believe what I was reading, I was so excited, was this paper. It came up in archive. It was a Microsoft team that got access to the OpenAI model, the new model, GPT-4, early. And they used this phrase, artificial general intelligence. Now, they definitely caveated it. They wrote sparks of. They weren't willing to go whole hog and say AGI's here. But they were saying that we have a hint of AGI. And if it's AGI, we're finished. We just plug it in, switch it on, and it's done, right? So this is the vibes 18 months ago. It seems like a long way away now. We live in the hard reality of trying to use these systems now, right? But this is the context under which this project started. And since then, we've had an unending series of stories of the S hitting the F, right? The early signs happened in June 23 when the lawyer got in trouble from a judge because he used ChatGPT to cite court cases, and ChatGPT hallucinated. We all learned that our computers can have dreams. There was the Chevy dealership who plugged ChatGPT into their customer support system. It started recommending other cars from competitors, which is very funny if you're a Chevy. There was Air Canada, famous case. This is the case I see cited most often. The chatbot basically hallucinated a policy that wasn't real, and then the guy took the airline to court and they were held liable. GPT-4 jailbreak subcommunities on Reddit. These things are very active. People love to jailbreak AI, and if you don't know what jailbreaking means, it means tricking the chatbot, the LLM, showing it some text that changes its instructions so it does what you want it to, not what the developers envisioned. In other words, you can get the AI to say anything you like. And then the New York City AI chatbot that told businesses to break the law. That's not great for a government chatbot. And I couldn't resist but laughing at the Google one, where when Google released their chatbot, it started recommending we use glue to get this cheese stick to pizza. Now, this is what it's looked like when people started building on top of these systems. And we're building our system for the UK Foreign Office. And now imagine this. Imagine if every one of these horror stories happened on a gov.uk domain on the UK Foreign Office website. Imagine the damage I could do, right? Imagine if somebody was jailbreaking our system and making the AI say something bad about the incoming American administration or something really controversial about one of the major conflicts in the world. And this is why when you're building this kind of environment, you can't really go in naive. You need to really think a lot about the context you're in, the use cases and stuff like that. And it puts a lot of constraints around about what you're doing. Let's actually look at the use case. So the UK Foreign Commonwealth Development Office, which I'll say Foreign Office for short, or the FCDO. So they have 500,000 inquiries a year, right? Customer contact center inquiries. Why would people be getting in touch with the Foreign Office? Well, if you're British, you're overseas, you've been mugged, you need help, you contact the Foreign Office. You've lost your passport, you need to come home next week, you've got no passport to fly, you contact the Foreign Office. Maybe you want to travel to China, you're not sure if you still need to get a COVID vaccine or not, you'll go check the Foreign Office, etc., 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 right? So there's a sort of cadence of these things coming in, about 500,000 a year, and that's fine, right? It's a big number, 500,000 inquiries a year to have human beings answering them, but you can plan a contact center to do that. What you can't do is do that when there's an international crisis, right? There's a flood in Spain, and all of a sudden you've got thousands of British nationals needing urgent, immediate, genuine, one-to-one assistance. Well, the guy that's lost a passport is going to be way down that list, right? And you might be waiting 2 to 10 days. And if you need to come home next week, that's a problem for you. So this is the problem. It's not the volume they can't handle. It's a challenge, sure. But it's the spiky nature of it. It's literally impossible to predict. And the world is so full of chaos that these crises happen all the time. And this is why they wanted to bring in us to build some support. Basically, our job was to try to reduce this 500,000 down while still giving people the information that they need. Let's have a quick look at it. I'll just go to an embassy page. So this service is live now on every UK overseas embassy. There's all this information about what the embassies do, and at the bottom you can contact for help. I'd like to point out that the first major thing to think about in the real world use case is that most of what we're doing here isn't AI. Actually, most of the way that we reduce that 500,000 down is by just good old-fashioned service design, right? It's not about technology, it's about solving a problem. So these things here you see, these are actually the most common reasons people will phone the Foreign Office or email the Foreign Office. So if you could just click on it, I've lost my passport, yeah, I'm traveling really soon, yeah, I'm British, and I do have a passport that's recent. Boom, it's going to take me to literally straight to the form that I fill out to get my replacement document, right? My emergency travel document. If I wasn't traveling so quickly, then it would basically just tell me to get an ordinary passport renewal, right? So like, it seems silly, it's not AI, right? But actually this is what good design looks like. It's not about technology. Good technology just supports good design. If you're a British person and you need emergency help, we're not trying to stop you contacting the Foreign Office. You just confirm you're in Germany, you're in Berlin, and there's your phone number, right? So this is not actually about being averse to the people that need to talk to the government. It's about the people that actually don't need one-to-one service, that just need to get the answer. So let's look at that, right? So I'm in here, let's say a scenario. So I'm a Scotsman in Germany, and I've met someone, oops, can't type here. And I've met someone and I'd like to get hitched here. How do I do it? Also, I think I want to work in Germany. Do I need a visa? Well, what do I need? Let's not be so literal. What do I need? So, you submit your question, and then in the background, we're kicking in using some OpenAI API stuff here, which I'll get into some detail in a minute, and it's going to give us the answer. So you see here, help for British people getting married, registering a civil partnership abroad. That's the form you fill out to get your certificates and stuff, and there's visas for working and living abroad, right? So this is the AI solving that problem for us. Let's figure out how we did it. Now, I don't know, I get the impression some people here are new to AI and some people here are gurus. If you've been looking at it for any amount of time, you'll already be anticipating this technique called RAG. You'll hear it all the time. It sounds really technical. It's a really simple concept. The R stands for retrieval, which means go grab some documents. It's like look up a database, right? Go get something that's going to help the AI answer the question. And then the A and the G is just augmented generation, which is a hard, fancy way of saying show it to the AI and tell the AI to use this stuff we just showed it to answer the question, right? It turns a conversation with ChatGPT into a reading comprehension test. And a really good way to imagine it is like, if I wanted to ask ChatGPT a bunch of questions about an obscure Scottish poet, and I just pasted the Wikipedia page into ChatGPT and said, could you answer these questions about that poet? You've just given it the answers, right? So it's reading comprehension. That's what RAG tends to be. And people are very excited about RAG because it is very, very powerful. And really good news, if you want to put a system together like this, it'll only take you 10 minutes on one of these very many happy and enthusiastic young YouTubers who will show you how to do this. And they're not lying. It actually does only take about 10, 15 minutes to plug this in. But that's the allure. That's how you end up with that Chevy dealership problem or that airline Air Canada problem. Because the difference between a little prototype that blows your socks off and a product that's robust against all these edge cases is a ginormous gulf, and that's actually where most of the work was in our project. This is what RAG looks like. This is actually OpenAI GPT-4 behind the scenes. Doesn't look like it because we built a little toy interface on top of it using a thing called Gradio. But this is a real question that somebody asked, right? We land on the 1st of January, got a return flight from the Philippines 1st of February, and we're only overstaying our 30-day visa by 12 hours, right? There's a free 30-day visa. And they're going to be staying for 30 days and 12 hours. And they want to know if they're going to get in trouble, they're going to get fined. And they've got this genius idea. What if we just fly to Vietnam in the middle and come back again? Is that a new 30 days? And you look here, these two bits I've highlighted. This is the AI answering the question, and behind the scenes we've plugged a RAG system into it. So what's happening is, it's taking the question here, it's going to the Foreign Office travel advice web pages, which is this massive list of all this advice about going abroad, and it's bringing back the stuff that it thinks is relevant, and it's using that stuff to answer the question. So see here, based on information provided, so it's read it and it's using that information to answer the question. And I really like saying this, right? The information provided doesn't specify. That's great. You don't want the chatbot winging it. You want it to stick to the information specified. So this is why people really like these RAG systems, and this is what is good about them. A hint for you though, it didn't quite work out straightforwardly for us, right? And I'm going to take you to why that happened. But in order to take you why that happened, I do have to get into a little bit of the detail on how RAG systems tend to work. Now, they don't have to work this way, but basically, when people talk about RAG, they're talking about using vector embeddings similarity search, which I'm sure you're all intimately familiar with, right? But ultimately what happens is you've got an AI system called an embedding model, and it takes a piece of text and it turns it into a number. It turns into like a number, you could think of it like a coordinate. So you see this 88, 54, 64, blah, blah, blah. It's like X coordinate, Y coordinate, Z coordinate, and it just goes on. It goes on for like 4,000 numbers, right? It's a long vector of numbers. And when you give it any paragraph or any word or any sentence, you just give it a bunch of text, it'll give you back a number that represents that text. The one thing you need to understand about it is that the coordinate location means something. Now, you don't need to know what it means exactly, it's just that's where the meaning of the paragraph is. So see these two paragraphs here, entry requirements and visa requirements. They're different, but they're kind of similar, right? So if I was to plot the coordinate system, entry requirements is going to maybe be over here, visa requirements is going to be over here, because they're different, but they're kind of similar, whereas healthcare facilities in the Philippines is going to be further away. That's the only thing you need to really understand here, is that the meaning of the words in the text get turned into a coordinate, and things that are nearby each other in that coordinate space kind of have similar meanings. And this is what powers all of these RAG systems, because you ask a question, do I need a visa for the Philippines? You turn that into a coordinate, and then you bring back all the data that's nearby. And that's how we do the thing I said to you, where if you want to ask questions about a Scottish poet, you paste a Wikipedia page in. This is how it does it. Because if I asked a question about Rabbie Burns, he's not obscure, but tell me about Rabbie Burns. It'll create a little coordinate for Rabbie Burns, and in the database are all the Wikipedia pages for everything. And the Wikipedia page about Rabbie Burns will be quite close to my question because it's also about Rabbie Burns, right? So the whole premise hinges on the idea that the text is like, the questions for the text have some similarity with the answers, and that's how you find it. That's how you power your RAG systems, right? Let's go back and look at those answers I showed you earlier on, right? This is the answer I showed you. And the last time I highlighted based on the information provided, which I told you was a good thing. But you know what's not a good thing? This word here. Right. Based on information provided, if you're only overstaying your 30-day visa by 12 hours, it is unlikely that you'll need to pay a fine. That's a curious word, unlikely. Does it say unlikely in the Foreign Office travel advice for the Philippines? I don't think so. Actually, I know it doesn't. And we asked the question, like, do you get fined in our subject matter experts in the Foreign Office said, we don't know, we'll have to speak to one of our policy advisors. So like, this is not actually in the text, right? So the chatbot is telling us based on information provided, but it's still going beyond it, right? Now, we like the bit at the bottom where it refused to answer. I asked the same question again. There's a bit of randomness when you ask these questions. This one here looks really good, right? It refuses to speculate, but this here, the fine is 1 million Indonesian rupiah. That's not even the right currency. Big shocking moment there. So we obviously couldn't do something like this, right? This is exactly how you get yourself in trouble. This is exactly what went wrong with those examples. Luckily, you don't build this stuff in isolation. We were supported with some really good guidelines from the Cabinet Office, who provided a bunch of principles for building generative AI products. And if you look at the first two principles, understanding the limitations of generative AI, you cannot guarantee that it won't make up a hallucination. It's a probabilistic thing. Every word has a percentage of being chosen. I don't care if the correct word is 99% likely to be chosen, 1% of the time it won't. And that word unlikely was the mistake there. And now we're giving advice that could put a British national in trouble. It's not ethical for us to have gone live with a system like that. So we didn't, we did something different. And this is the big takeaway. This is the first big takeaway of how we were able to go live with that system I showed you that looked like it was generating an answer live, but it wasn't. what it was doing is we're using the brain of the AI. The power of ChatGPT isn't that it can speak. Yeah, it's amazing. But it's also that it can understand that language. It can really build an understanding of what words you're saying to it. So we use the AI to understand the text, but not to generate the text. We use ChatGPT without the chat, basically. See this little packet of data here? This is representative of the data that we send from the AI back to the front end, the web server. And the web server will be looking for the ID number. In this case, it's answer ID number 8. And it's just going to load up answer number 8, and it's going to just render answer number 8 to the user. So it's not generating the answer at runtime. It's understanding the user's question using the LLM, and then it's picking the answer that best matches the question. And it's a pre-written answer that's written by a human being. It's completely safe. It's already approved. There's nothing dangerous or dodgy in that text. And that's what I meant about compromises, right? It's nowhere near as cool as a live chat answer, but it's a heck of a lot safer, right? So user sends the inquiry in. We do something like retrieval augmented generation. We bring back possible answers. The AI will pick the answer and it'll pass the answer back to the front end, which renders it. And the good news here is that it completely eliminated the risk of hallucinations for us. No more of these dangerous, I mean, it can still hallucinate, but it can just hallucinate a different safe answer. You've asked me about a visa to China. I've told you about taking your pet to France, right? It's a weird thing to do. You're going to be thinking my AI is stupid, but it's not going to put you in jail. It's not going to give you a piece of advice that will get you in trouble. So the good news is no hallucinations. Bad news is it didn't work at all for us. And the reason it didn't work at all for us is because of that exact thing I was trying to teach you a wee bit about with the embedding similarity searches, the coordinate stuff, because we have a data problem. The answers that the Foreign Office give the users, they don't directly and exactly answer the question you asked. Instead, they direct you to the website page where you'll find the answer. So for example, this here is the answer that we will serve if you ask me if I need a visa for the Philippines. Read our foreign travel advice, which includes information about this. That is also the same answer for which areas of Egypt are safe. It's also the safe answer for which vaccines they need to go to China, or is it safe for a gay couple to visit Saudi? So you see here, that premise, that thing that your RAG systems hinge on, that if I turn the question into a coordinate, it will be located really close to the answer because we've got similar meanings. It doesn't work for the data that they use for their answers, right? The answers that the Foreign Office gives are too generic. So we had to change our approach. So we ended up creating this intermediate representation here. And these are the names of the answers. So these are the answers. This one here is getting married abroad. And instead of it being you can find the latest advice for, we wrote here a bunch of reasons that people would be presented with the answer. So it might be easier to look at the travel advice one, right? So yes, it's got some bullet points here, but there's maybe another 20, 30, 40 topics that we would also want to serve your travel advice. So we literally just wrote down all the things that we think you would want to be given travel advice for in a big list, and we put that into the database. So we're rebuilding the connection between the embedding of the question that you ask and the embedding of the data that's in the database. Now, initially we didn't start with a RAG at all. We just built this into our prompt, and it worked. But look at that prompt. That is just so many words, right? And apart from the fact that it's wasteful because you pay for every single word, it's also quite hard to maintain. It's quite hard to read. Anytime you're adding another answer in, you have to add another line, and it's just, it grows and grows and grows and grows and grows, and it doesn't scale very well. So we ended up going back to the RAG thing and combining the two approaches. And this is going to be, like, you'll understand this if you've been playing with RAG at that level. It might be a wee bit hard to get your head around if you haven't. But you see where it says notarial general, right? That's one of the answers, right? And see each of these separate boxes here. You can't see, this is a spreadsheet. The projector is blowing out the lines, but every line is a new entry. Each one of these on their own is what we would put into the database with an embedding. So that one answer is represented by 9 separate coordinates in that database. Getting married abroad is represented with its own set of like 10 or 15 different topics. So when you ask a question, hey, I need to get my document stamped, it's going to recreate the behavior of the naive RAG system. But the difference is we handcraft the embeddings instead of them happening by magic because of the data. So you see here, notarial services, is down here. Needing to prove a document is authentic for the purpose of being married abroad is nearby. Write a statement of fact to help British nationals with local authorities prove wording is correct and unambiguous is here, whereas buying a house or owning a property abroad is over here. So when you say to me, hey, I'm trying to buy a house and they told me I need to get some kind of documents, what kind of documents do I need? It's going to be closer to these kind of coordinates here, which all pertain to the correct answer. So I know that's a wee bit in the weeds in the techie here tonight, but I thought it was worth sharing. And then when you get the match, we bring back a bunch of logic, and it's the logic that gets shown to the AI. So that first thing, the RAG thing, just finds an entry for the Wikipedia page, to use that analogy, right? But the stuff we show the AI, we don't show the AI the answer, we show the AI some rules, and the AI picks based on the rules. So these are reasons to pick Notario, these are reasons not to pick it. These are reasons to pick getting married abroad. These are reasons to pick the legal matters one. So if most of the time people asking for legal help, and they're not in danger, they should be directed to this template which describes how to find an English-speaking lawyer abroad. That's what the AI gets to see. And if you're asking a question, hey, I've been arrested, I don't know what to do, maybe we send you that, but why would you not pick it? If it's an emergency or an extremely serious matter where lives are at stake, don't choose this. So you see here, we're kind of combining like a bunch of rules you would show a member of staff with some technology here, because the AI is able to read these simple instructions and kind of figure out what to do. So it's a very sort of novel, bespoke kind of way we built it. And this is actually not even the final. Oh, you can't see it at all here. Well, it looks really nice on my screen. Well, I'll just tell you that these three black boxes here are three different stages where we use LLMs, right? So the first thing we do is the user never asks a simple question. They always present you a big paragraph explaining their situation, and they ask for help. So the first thing we have to do is we have to use an LLM to extract some questions to answer. So we have the LLM bring out up to 3 separate questions. You noticed I asked 2 questions in my example, and it got me 2 answers. So we don't take the paragraph as one question, we decompose it into up to 3 separate questions. And then we go down and we do that thing I showed you where we bring back the context, and we ask the AI to read all of those rules and to pick the favorite articles. And then the last thing we do is we pick a heading for each section. Now, that one answer for travel advice will be given to like 20, 30, 40 very different answers. So if you put a heading above it that really closely matches your question, you see the connection there, and it makes it feel like you're getting a really personal answer, even if it's not that personal. So you see, it's like half real AI, half handwritten human content. This is an example of what the AI gets to see in the end. That's the same equivalent of that horrible purple prompt, but you notice it's only looking at like 6 to 10 articles at one time. And it's saying, choose this template for this, choose this template for this, choose this template for this. It's all these rules it's going to read, and it's going to decide what to pick. So that's the second big takeaway, right? Think about how if you have been in the space for a minute, you just anticipate RAG. It's clearly how everyone approaches this. But like it really depends what your data looks like, what's happening in your system, right? Our data, when we finally got access to these answers that they send, we realized they'd never answer the question directly, because of course you don't want some random guy or girl in the contact center just interpreting the advice. You want to send the person to the web page where you pay a lot of money to get that exact text written as clearly as you could, right? So it's obvious when you think about it that they wouldn't be answering these questions on the fly. But until we saw the data, we didn't realize it. And then all that stuff about the representations and the embeddings really depend on your data. Extract, transform, load has been a part of all machine learning systems forever, and it's going to stay the same for sophisticated LLM-based tools too. We first went live on one of the embassy pages in April, and it's been going live, rolling out. It's rolled out all across every embassy page now, like 250 some pages. And another one of the principles that we made sure we hit every one of those CDDO principles, the Cabinet Office principles. But one that really powered the system was to have really meaningful human control at the right stage. This was core, not only to building confidence in the team, but also building quality in the product. Because you saw that like those rules were written in English. We wrote down, hey, you should pick this for these kind of things. How on earth did we create that? Well, basically, this is a service that's been live for many years. They have thousands of questions and answers. So they would give me a batch of 100. I would run them through the LLM, and it would do sort of a terrible job at the beginning. And then I literally would sit down with the subject matter expert. We would sit together. We'd review the outcomes of my LLM's choices. And they would basically tell me all of the ways, oh, yeah, that is a visa question, but this person is wanting a visa to come to the UK, not to go out. So really, we don't want to give them the visas page. We want to give them the UK visas page. And I'm like, okay, fine. And I put a rule in there. give it the UK. So it's all written in plain English by just communicating. Basically, the subject matter expert was fine-tuning my brain, and I was typing it into ChatGPT. So I would update the rules, and then we basically repeat it again. And we did this every week. So and the good thing about every week, I would basically keep tweaking the rules till I'd get back up to like a really good score. And then she would give me a new data set and my score would plummet. And that's great because it means I'm not overfitting the data. So basically, we just kept building it back up again until it got actually pretty good. And we left the team, we've finished the project now, right? The Foreign Office have this live, but they have this tool in the back end where they can edit the rules, right? So they don't need to pay consultants to come in and to maintain this. You can't really read the text, but these wee things here, these wee things in the boxes, those are the individual coordinates in that embedding space. So if you think, oh, if somebody asks if they could take chewing gum to a country, you need to give them this page. You would just say, any questions about chewing gum? Boom, and it will put an embedding in there, you know? And this bit over here is where you do the actual rules themselves that the AI will read and decide whether or not to make it. And what's really cool about this is that the team have been adding content even after we stopped, right? They added content about the FIFA thing, the European Cup that was happening. They added content about the Olympics that was happening. We didn't have to do anything. They built all up themselves. This is the impact. This is the big thing that actually means it's a success story, right? Remember that thing at the beginning, $500,000 a year, crisis hits, you might be waiting 10 days, it's down to less than 5 seconds, you saw it live, right? Up to depending on which part of the world you are, and you know we have different behavior in different regions, 85 to 95% of the people finish their engagement by just clicking on the conversion, i.e. they go to the form, they fill it out, they get the thing they're looking for, which is excellent. I didn't actually show you on the screen, but if I just scroll down a wee bit, you'll see a thing that says if you didn't like this answer, you can reword it, or you can just contact a human. So you can still very easily send the email in the old way you would have. When people do that, the AI was actually correct 95% of the time already, which means that people just didn't like the answer, but it was the right answer. So the contact center actually thought their system was broken for a minute because they had so many fewer incoming inquiries, dropped 80%. I mean, that creates to a lot of value in terms of staff time that could be repurposed, you know. And an interesting thing that we found was that the queries that do come in now, they tend to be quite sophisticated inquiries, right? People aren't saying, do I need a visa to go to America? They're saying, can I take this specific heart medication to America? That's not an answer you'll find on gov.uk, so of course they have to come in to get that help. So there you go, that was the whirlwind through our case study. Happy to answer questions. If you'd like to get Caution Your Blast to help you build stuff, that's Caution Your Blast here, and that's me up here. Thank you very much for listening. Yes.
So the interesting sort of coordinate space.
Yeah.
That's just it's got a lot of dimensions.
Yeah.
That's inside the LLM, is it?
So it's, I mean, the truthful answer is there is a version of that inside the LLM, but not really for what we're talking about. So I had difficulty getting my head around this the first time I came across it. So the purpose of that retrieval augmented stage, right, retrieval stage, is just to get some data to show the LLM, right? Then you paste it essentially into the chat box and you send that message in. So when we send those messages to OpenAI, they are not dealing with it in that coordinate space. They're literally seeing the literal text of this, right? So it's a precursor to an LLM. You can think of it. An embedding model is like an earlier, like this, you know, ancestor.
You sort of bolting onto the front of ChatGPT.
So we didn't build the embedding model. We used a OpenAI embedding model. So embedding models is a whole class of AI on its own, and you can fine tune them to perform better on your data. You can get embedding models that, like Spotify, when it's giving you your recommendations, it's based on embedding models. They've got coordinates for your songs and all that kind of stuff, right? So we use the OpenAI ones, but you can use anyone.
So it's called an embedding model.
It's called an embedding model, yeah, and it returns an embedding, which is what they call the vector of numbers for the input you give it.
Which effectively is sort of a multi-dimensional semantic space and
yes.
Sort of semantic distance between one thing and another.
Yeah, it's a latent space representation. So you're losing some detail when you create a coordinate system, right? Obviously, but it captures an awful lot of detail, and it's something.
That's really interesting. Me and Pete developed a very primitive model many years ago. Effectively, I've now realised that's what it was.
If you look up word to vec math. Right, that's kind of one of the big moments, right? But they discovered that like this was just individual words, right? Vectors for words, and the word for man and woman have a distance between them. If you get that distance and then you apply that distance to the word king, it takes you to queen, right? And that's when we started to realize that meaning was embedded here, like proper actual meaning. Like, and then, so anyway, so it's an earlier ancestor of where we are now with LLMs, and but in our system we do that first to bring back the text like this, and then we send that text into the LLM. Yeah. Behind yes.
It's the embedding, like it's the word probability of the word.
It's based on that kind of a thing, but so the original transformer had like two parts, and the first part created an embedding representation, and it is sort of based on that, but it's like it's doing that attention thing where each word is like, if I said to you, we're getting into some stuff now, but if I said like I went to the bank, you're gonna have a mental picture. If I said to you I swam across the river to get to the bank, you have a different picture, right? So if you think about those, what happened there? The word bank got moved over here by the other words around it. And now imagine that, but operating in an entire document scale, right? So when you go through the entire process of the whole document, you're kind of navigating a pathway through possibility space, and you're ending up over here for one paragraph, and a different paragraph's going to end up over here, you know? If I said cat, or if I said katza, they're different languages, but they both mean cat, so they won't be exactly next to each other, but they'll be really close, you know? And so it is a kind of probabilistic thing. You train it like you would train a full large language model, but it's like it's a different, it doesn't generate, it just outputs a number at the end. Yes, over there.
So two questions. Is there any similarity between that and cosine similarity?
Cosine similarity is the formula that you use to determine the distance between the two coordinates. So when I was saying you bring back the nearest neighbors, what you do is you bring back the nearest 5 or 10 articles based on cosine similarity. So actually it is literally, that's the distance measure, you know? So that's the formula you would run to calculate. So this one, cosine similarity will be like whatever, 0.9. This one, cosine similarity will be 0.4. So that's basically the math that underlies it, yeah.
Thank you. And in that little analogy you gave a moment ago with the swimming across the river,
yeah.
How does that relate to what's the probability of?
So it's, you train these things by, very similar to the way you would train large language model, it's predicting the words that come, and it starts to learn that certain words could be substituted because they have similar meaning. And, but it's just trying to find the most efficient way to represent all of the tokens essentially. So once you put that condition on it where it's trying to be really, really efficient, it will sort of naturally guide itself to these groupings and organizations. It's efficient to have all these words similar because you can have a similar meaning at the end of the journey, even if you went to man instead of like gentleman. It's got similar meaning, so it's efficient to do that. So you put these efficiency goals on. That's a bad explanation, but it's best I can do without. Yeah.
A gentleman and a man.
Yeah.
Boil it down, right?
Yeah.
You don't need both words.
Yeah.
I'm curious, is it expensive to run, and how does it perform on the high loads? Did anyone try to abuse it by just DDoSing a bit?
So it's cheaper significantly to run than is to do this with people. We did some cost modeling, and I forget, was it about 11K or something, the high-end estimate?
It was about, with the
original tokens and everything? Yeah.
They were about, I think it was like $3,000, but then you once you go beyond that, you need excuse me, you need to put a lot of inquiries through to get your money back. The more you use it, the cheaper an open source model would be.
Yeah. I mean, basically, it's quite cheap to run, right? And the price plummeted in the year we built it because they keep cutting the costs. They're basically subsidizing it because they want to steal the market, right? So every time we wanted to, our natural predilection is to use open source, right? So our natural vibe is to use one of the Llama models. But every time we went to model how much it would cost more than just bloody well using OpenAI. And then OpenAI made it cheaper, and then they made it cheaper, and then they made it cheaper and cheaper. So in our actual one, the one that we pushed live, this one here, which I know you can't see the colors and all that, yeah, it looks like this, right? So it's a proper Miro board swim lane thing, right? But whatever. We're using GPT 3.5 there, And we're using GPT 3.5 here. So this is to do the extraction, trying to find questions in your paragraph of text. And this is to pick the best heading. So for each of the answers, we've got like 100, 200 headings we could choose. And this one's the closest to user's question. That's an easy task. So you use the cheapest, quickest AI. And the bit in the middle is the tricky bit. And we were using GPT-4 for that. Of course, those models end of life, and it'll be 4.0 mini and 4.0 basically in a couple of months.
And OpenAI scales for you.
I mean, it scales. It's OpenAI inside the Microsoft Azure infrastructure. I skipped all that stuff, but all this data protection stuff, UK, nothing can leave the UK. We strip all the personal data in this brain here. That's Azure Cognitive Services stripping out personal data. But it scaled well for us. Yeah, it scales fine. At the back, yes.
I'm interested in what you were saying about taking that iterative approach.
Yes.
To rework like the rules of the prompt.
Yes.
When you do that, is it more effective to say, like to have your original prompt and then you decide on like the feedback that you want to give it, the changes that you want to make, to kind of do that as an addendum, or do you have to keep going back into the original prompt set and like kind of making the changes in there?
Yeah. So we built a system that would take a spreadsheet. So you see this here, this is, so our prompt looks like this, right? This bit here is always the same. This bit here, which is specifying the output format, the JSON format, is always the same. This bit in here is 1, 2, 3, 4, 5, 6 individual rows from the spreadsheet. And the rows, so we basically had a system where we would be able to convert initially a Google Sheet, or whatever, a spreadsheet, I think it was Google Sheet, but literally a spreadsheet into a CSV and then bring it in, boom. Over time, we then replaced that with the maintenance tool, which is this, and it's so much easier to work with. So what you do here, again, you can't read it well, but that's his travel advice, so click on travel advice. And these are separate pages, like you can click on, and this is basically the embeddings. So you can just enter one, you can delete one or just put one in, and these are the rules. It's a good choice under these conditions, it's a bad choice under these conditions. So that's how, the contact center are not technically trained people, but they're all doing prompt engineering. They don't know they're doing prompt engineering, they just know they're updating their tool to give answers. But that's what they're doing. But like behind the scenes, we pay, their stuff turns into this as a result of that system,
Thanks.
No worries. Yeah.
So I have two questions. So when you interact with ChatGPT, the response is really quick. But when you put this whole model in place, the RAG, the unit control, how good is your latency and how do you ensure it's as quick as possible? So
the latency is, it's always sub 5 seconds, usually about 3.5 seconds. It will be much faster when it moves from 3.5 and 4 to 4.0 mini and 4.0 because they're both faster than their predecessors, right? But it's about 3.5 seconds just now. The latency is, there's 3 separate calls, right? The GPT 3.5 call was basically like almost real time, like less than a second. GPT 4.1 in the middle was like 2 and a bit seconds, right? And it was worse when we were sending the ginormous like mega prompt, the big purple thing I showed you, because that's obscene, right? It's got loads of tokens to read. But the reason we chose the lighter model is partly because of latency, right? And cost. But you want to do as few of these things as you can. The retrieval part was actually it's negligible. It's not even worth mentioning. It's a couple of milliseconds compared to, so the latency is ginormous comparatively from sending a message all the way to OpenAI, them spinning up the GPU, embedding all of your tokens in the way and generating the answer. That's where the latency comes from. But they are heavily motivated to do it quickly, and GPT 4.0 mini is really fast. And we finished this project before those things came out, before mini came out. But basically, once you get it stable, you don't always want to go in the fastest thing. You want a thing that works, right? And sub 5 seconds is really exciting. You saw me do it live. It might not have been as instant as you would love, but it's fine, right? And it's way better than 10 days. So it's not always about it being I would prefer stability over shaving a second off, right? But we will have to upgrade the models anyway to the faster models because they're end of lifing 3.5 and stuff like that, Oh, you got another one? Yeah.
So when you pass everything to the ChatGPT API, how do you ensure the data privacy? Yeah, so it's not going to OpenAI, it's going to Azure, which is Microsoft's cloud. They've got a version of OpenAI they can put into your paid for commercial tenant, your servers.
And that's what we do. And we ensure that so we do a bunch of things. So first of all, we strip all the personal data out using a lightweight AI called through cognitive services. And then we've configured it to only use the Azure OpenAI endpoint that the government pays for inside the government's infrastructure. And the only logs that are kept for 30 days for abuse detection, but there's no other logs kept. And that's the kind of stuff you end up needing to do in these regulated environments that you wouldn't maybe care about for a random toy use case, you know? Yeah.
Is that OpenAI itself not talking back to OpenAI HQ though?
So when you do it inside Microsoft Azure, Microsoft literally have a copy of the model in their infrastructure, right? So if you were to get an AWS server or a Microsoft Azure server or a Google Cloud server, and you're paying for your own dedicated unit, you're paying for your own dedicated unit. So I think the GPUs might technically be shared between multiple clients, but it's all, Microsoft are basically ensuring the data is not leaving your zone, basically.
So it's going to learn in your direction and it's not going to take it back to central ChatGPT then?
It's not going to learn anything because when you go through the API, whether it's with OpenAI or with Microsoft Azure, the contract that's there states, now you have to trust, but the contract states that they do not train on the data you send. If you use ChatGPT through the web interface, they'll train on that. If you go through the API like a programmer, then they don't train on your data. So that's always the case for OpenAI, but it's doubly the case when you go through the Microsoft Azure. Because there's a really serious contract between Microsoft and the government. Microsoft don't want to fuck that up, you know? So it's protected by law as much as it is by technology. But the Microsoft have their own copy of the, somebody asked the question, can you run OpenAI on your own machines? It is not something they would let you do, and it's way too big, right? You need like multiple of the most expensive, you know, servers in the world, right, with the best graphics cards. Microsoft have that, right? They've got lots of that. That's what they do, you know? So Microsoft have their own infrastructure copied. They have their own copies of the model, but they also don't train on your data if you go through the API.
We've got time for one last question.
Think about yourself, sir.
May I ask that if there is update of the policy, will you go through the whole cycle with the David again?
Yeah.
And how long does it take? And other member of the original and prior team, do they need to train up with you or something?
Yeah. So this thing here I showed, right, this is the way you maintain it now. And we stopped being the people editing the rules about 2 months before the end of the project. So policy did change several times, right? It changes all the time, right? And they were doing it. So they don't need us, right? And they did it by going in here. They click on the answer they want to change the rules for, and they literally just change the text, right? They write it themselves. There is a test suite. You can't just hit publish, right? You could do some crazy things. So there's a test suite with a couple of like hundreds, or I think maybe, I don't know how many, but many answers that basically show good coverage on all previous known. So basically it's an eval data set we have. And you click the button and it will run through your latest version, and you have to reach a certain threshold that's like a policy level in order to make it go live. So if you change a rule and it breaks something, you can't go live with it. And I think we're done. Thank you very much.